Okay, we're using implicit differentiation to find the derivative of 9 cosine xy is equal to 2x plus 8y. Okay, the left side, you got to keep in mind that the left side is using not only the chain rule, because it's xy is inside the cosine function, so that's the chain rule. You're also using the product rule when you do the inside derivative, because the derivative of xy is a product. Okay, but we can do this. Okay, so let's find the derivative of both sides. Okay, the derivative of the left side would be 9 times. Okay, the derivative of cosine is negative sine. So the derivative of cosine of xy would be negative sine of xy. I'm going to put the negative in front of the 9 though. So we have negative 9 sine of xy for the outside derivative. Okay, times. Now we got to find the derivative of xy. Okay, now that's the product rule. Okay, so I'm going to use the derivative of the first times the second plus the derivative of the second times the first. So the derivative of the first function is x. The derivative of x is 1 times the second function y. 1 times y is just y. Okay, so plus, we're going to add that to the derivative of the second. The derivative of y would be 1 dy dx. Okay, times the first function, x. I think it looks a little better to put the x in front. Okay, so that's the derivative of the left-hand side. Okay, the derivative of the right-hand side. Okay, the derivative of 2x is 2. The derivative of 8y would be 8. Okay, but because it has a y, we got to put a dy dx after it. Okay, so we have kind of a messy equation here. Now, eventually, we need to get all of our dy dx's together. But we need to expand the left-hand side with the distributive property first. So we need to take negative 9 sine of xy times each of those terms. So when you take negative 9 sine of xy times y, we have negative 9y sine of xy. Okay, taking it times the second part, we would have negative 9x sine of xy dy dx. Okay, I'm just going to copy down the right-hand side, 2 plus 8 dy dx. Okay, now we can get all of the dy dx's on one side and factor. Okay, so I'm going to add a 9x sine xy dy dx, just because that happens to be a negative. So my right-hand side, on my right-hand side, I'm going to end up with a positive 9x sine of xy dy dx. Okay, I already have the 8 dy dx over there already, so I'm leaving it there. So all my dy dx's are on the right. Now I need to get everything else on the left. Okay, the negative 9y sine of xy is already on the left, and it does not have a dy dx attached. So I need to leave it there. Okay, that positive 2 on the right, I need to get that over on the left as a negative 2. Okay, it's like I'm subtracting 2 from both sides. Okay, now I have everything on one side that has a dy dx with it. I have everything else on the other side. So now I'm going to factor out a dy dx on the right. Okay, when I do that, I have 9x sine of xy plus 8. Okay, on the right side, I'm sorry, the left side, I have what I started with, negative 9 sine of xy minus 2. I'm almost done. I just need to get dy dx all by itself. Okay, so since dy dx is multiplied to this big messy expression, 9x sine xy plus 8, I can divide each side by that. 9x sine xy plus 8. Divide the other side by the exact same thing. Okay, once I do that, I can factor out the 9x sine xy plus 8. So my dy dx is equal to what I have here on the left. Negative 9y sine of xy minus 2 all over 9x sine of xy plus 8. Okay, I hope this helps. I appreciate you watching.